Now this video deals with sizing the primary overcurrent protection device for transformers rated 1,000 volts or less, primary or secondary. Now we're going to review 450.3b as well as table 450.3b. Now, first of all, we want to determine what is the full load current rating of the transformer. And basically, table 450.3b divides these current levels into three levels. The first level is 9 amps or more, and you'd use 125% times the transformer's primary full load current. And you're allowed to advance to the next size overcurrent device above the 125% if it became or should it become necessary. Now, the second level of current is less than 9 amps but 2 amps or more, and you use 167% times the full load current rating of the transformer. Now notice there's no note 1 beside the 160%, so you can't move up above the 125%. You must be below the 125% if it's not a standard size fuse or circuit breaker in some cases. And then the final level would be less than 2 amps. We'd use 300%, and again, we cannot go above the 300%. We'd always have a round down size. However, if you had nuisance tripping, you could refer to, for a control circuit, you could refer to 430.72 C as in car 4, and you could use 500% if it became necessary where a controlled transformer was involved and you wanted to prevent nuisance tripping. Now basically those are the requirements of table 450.3b. Now we want to review our figure 20-11A. And we again want to find the full load current rating of the transformer. Now, if you notice in the information in the illustration that we have a transformer that's rated 50 kVA, 480 volt 3-phase, 208 volt 3-phase, 3-wire, or I should say primary is 3-wire and the secondary is a 4-wire. Now, the grounding, we would go to select our grounding electrode conductor from our table 250.30A5 and 250.66, as well as our table 250.66 were applicable. And then, of course, your grounding electrode that you would select is in 250.30A4. And, of course, if you have more than one electrode, they're all tied together to form an electrode system by 250.50, but usually we would ground to the structural steel. That's usually what the electricians do and the engineers want done. So now we're going to go next and apply the calculation and see just how we derive the size of the overcurrent protection device on the primary side when the full load current of the transformer is 9 amps or more and we're using the 125% requirement.